She graduated from lives in Indianapolis, Indiana, graduated from engineering of physics from Arcana University in Turkey. And then she studied studied a BS mathematics in Indiana University, continued her education with a master's in applied physics from Johns Hopkins University with her research area of physics of remote sensing and optics. She worked for Trimble for a few years, a Spectra Precision in Turkey for 5 years, and now she currently works for Seiler Instruments as a geospatial technical support and training for the last couple of years. So
basically some light coursework.
That's right. Some light coursework. Well, you should be able to share your screen now, Gizem, if you have a PowerPoint. So thank you for jumping on with us this week.
Thank you so much for your invitation. And I am so happy that I just have a great chance to have this evening with you. As Trent mentioned, I am from Turkey, and my background is not surveying basically, but I've been working for geospatial site for enough time. And today we will talk about two different sessions actually. The first one is traverse adjustment, and the second one is network adjustment. My prior role tonight is just talking about how we process the data in TBC. I don't know if all of you has any experience on TBC, or maybe you are all expert on TBC, but I will try to talk about how we can handle some basic features and some basis of the processing in TBC. I have two presentations, but I don't prefer to follow up all the slides since it's over 60, and probably we can finish on time with the actual software demonstration. So I will be sharing this presentation on somewhere Dropbox, and you can just check and refresh your mind. I will pass some of slides which has deep technical terminology and information, so you probably already know these details. I would like to start with traverse adjustment today. So basically, what we can do today is just talk about a closed loop traverse, and then how we can perform in TBC, and we talk about the settings, and then making a traverse adjustment, and review the results, and come back to settings, make a change on the settings, then readjusting the traverse. This is the first part of it. And the data we will use is basically something like this, and it's closed loop traverse. So our start station is station 1, and it's on a known point. And there's a backside of the start station, it's number 2. And there's a known coordinate on our azimuth. And you will see the start station 4 size to the intermediate station to the 5. And the last intermediate station, it goes to 6, and 4 size to end station 1, which is also start station. In this process, we will reference both end and the last station as the first station. So ending and the last one is the same. And then finally, the end station backsides the last intermediate station, and 4 size to 0.3. Since the start station is on known point, we can calculate the angular and distance misclosures. But if your traverse don't have any start or end station on a known point, you will only be able to calculate the distance misclosure. And once you finish your first traverse adjustment, all the intermediate stations in here will act like an start and end station for your second adjustment. This means your traverse is just dependent on the first one. At this point, we will apply a manual adjusting traverse adjustment. So means that there is an order, there is a sequence we follow up. And this sample data we will use today doesn't contain any vertical data. We will make a horizontal traverse adjustment. I try to summarize the process steps a little bit. So the data I'm going to use is already prepared by the Trimble under the tutorial materials. But if you have any data, you can import the raw data, which is unadjusted traverse data. And we will continue with changing the settings, the traverse settings over the project settings. Then we will come back to adjust traverse menu and create a name for our traverse, add our stations, and changing the station settings like start and end station orientation settings. We will check the adjusting settings and then apply the traverse adjustment. Then we're gonna see the results, and depending on the results, we try to change some settings and readjusting. Then just release a traverse adjustment report at the end. Okay, so these are the project settings we will apply. I'm gonna demonstrate on the software directly. This is the data we will use today for traverse adjustment. And our station, start station will be 1. And we will create a kind of loop around this shots, these observations, come back and end with station 1. Let me get this settings in here. Okay. I would like to briefly talk about the menu in Trimble Business Center. So under File, you can create a new project for your own data for your project. And you can select a template like survey food or metric system, depends on the unit. You will see the default templates that you can select, and you can create your own project. Then you will see the probably blank graphic view in here as the plan view. This is the 2D view. There's also a 3D view. Under Home tab, you will see the 3D view. Then you can apply the import button to bring your data into your project. TBC is quite practical software, so you can basically drag and drop your file like CSV file, your DAT level file, or JXL, JOB file, job files. And there are many extended formats that you can use. After you bring your data, and you just view your data on the plan view, you can also change the project settings. The project settings is advised by Trimble before you start any type of calculations, especially under the survey. On the survey tab, you will see the process feature codes on the left side, and you will see the processing baselines for GNSS, and under optical, you will see the adjusting traverse, level, and total station editors. And under the network, you will see the adjust network options. Coordinate geometry section shows you the transform survey points or merging or move the survey points. So before making the calculation, before starting your calculations, just check your project settings. Project settings is located on Quick Access toolbar on top of the menu. As soon as you click on it, you will see a left pane, bunch of folders, starting with general information, coordinate system, units, view options. This is already prepared project file, so there's already assigned a coordinate system group, and the unit is metric system. You can also check your unit and the coordinate system from status bar. It's right bottom of the menu on the screen. So right now we are on grid and metric system, and there is a zone as somewhere New Zealand. And you will also just manage the units like coordinates, distances, or vertical angles, area, volume, and azimuth values, angular values. You can change your units from there. And now for adjusting servers, which are current topic, we will continue changing the settings under computations traverse. Computations traverse brings us some of settings. First one is first two of our manual vertical and horizontal tolerances. Since we are interested in the horizontal tolerance, we can set, and I will set as, this is just a sample. You need to decide it. And I will set as 0.02, 2 centimeter to 5 centimeter. The maximum angle misclosure per station. You can also make a change on that too. I'm gonna set as, I'm sorry, this is going to be the 0.02 to 0.0. It's 2 millimeter to 5 millimeters. Okay. And I will leave the misclosure per station as 4 seconds, and I'm not going to change the minimum horizontal and vertical positions for now. What you can change is also point tolerances. Right now we have some of data. Let me show you the data first. Let's say OK. As soon as you click OK on the project settings, the change will be applied to your project. If the TBC requires a computation, you will probably see a red dot on your status bar. You can also compute your project from F4 or the compute project icon on quick access toolbar. Then all of your changes will be applied to the project. Project management is covered from Project Explorer. You will display all the imported files, all your stations, and your observations. You can also display the points. If you have feature code library, you can also display your feature code library or any type of data like point clouds, surfaces, anything. So you can manage all of your data from Project Explorer. And under the points, you can display all of your observations. If you click on point and click right, select properties, you can also display your points properties. So all your grid and local coordinates can be displayed, your layers and visibilities and your feature code if there's any. At this point, I will come back my project settings. Under computations, I will change the point tolerances. So for now, there are different types of quality Trimble provides. For your calculation, you can set the point tolerances according to the reliability of your data. If you feel like your data is very low quality, you can just change the mapping quality and then the tolerances for horizontal and vertical. And right now it's set as 5 and 10 meters. But if you feel like you have control points, you are more reliable data sets, So you can use the survey quality and set the horizontal and vertical tolerances for survey. If you don't know, you can just select unknown quality. This is generally used during the coordinate system settings. While you are setting your coordinate system, you pay attention on the quality that you have. You can also set your quality settings for the survey application, survey processing. And right now it's set as 0.02. You may have something different. I have already changed my settings. After you finish your settings, you can hit OK. You will see some points on the Project Explorer that are seen as red. So this red means there are some flags on my stations, on my points. If you click on this flags pane, you will be able to display what these flags refers to. And some of them are just exist the horizontal point tolerances and vertical point tolerances. The quality, survey quality, and the horizontal vertical tolerance values affect this flag. If I change my project settings, the survey quality, like something like 50 to 60, the precision decrease, but I will get rid of some of my flags. So this is one way to change it. Of course, this is not the best way to change it. And after you decide your point tolerances and traverse settings, when you set the traverse settings over project settings in here, after you decide all the angle disclosure values and horizontal vertical tolerances, everything, you can go to Survey tab, and under Adjust Traverse, under Optical menu, you will see the Adjust Traverse. It is quite quick. To start creating your traverse, you first click on Create New Traverse and name it. Oops. And hit on Create. This is going to be the manual adjustment. Under the mode, you will see two options, automatic and manual adjustment. Manual adjustment means that I decide the stations and I decide when I want to apply all these changes, all these settings in my project. Automatic adjustment applies the change according to the change on the settings and apply those changes on the points, on the computation automatically. But manually, you need to hit on apply and move. When you create the traverse name, you will see the stations container. Now I start my station with 1, but by clicking this arrow, you will display all the available stations. I'm gonna start with 1 in here. When you click on this little cross, it's going to continue. And you will see all the possible options, all the possible stations. And my order is, I will continue with 108 in here, that point, and hit on cross. It's going to draw on my graphic view. It's going to start drawing the traverse. And I'm gonna display other options. I don't want to end my traverse with the start station, so I will continue with the 109 and hit on that. So there is no other possibility, no other stations for those points, 110, 111, 112, but it stopped at 113. This means that I can pick one of those. And I will continue it with 118. Since 113 goes there and create a kind of loop around it, I just want to continue with 118, which goes there and create a kind of clockwise loop around my data. So as soon as we click on 118, I will see two options. 17, I can go up or continue in that way. I will remain as 119. And when I click on this, the loop has been closed. Since there isn't any other options, it's automatically closed the loop and ended with the start station and end station as one. I can display all the stations listed in here. If you don't like it, if you want to change it, you can remove it from your list. At this point, we have already created the loop. So if you delete one of these stations, you will continue from that point. And you can also display the settings in here, the start station orientation and end station orientation. These are the settings, other settings that we directly use for enhancing our results for the adjust traverse. The start station orientation, if you set one of your backside as a single backside, one of your station, it's only going to calculate that one. You can also set an azimuth for it. That's the same for end station orientation. As first, we will set all available backsides and make all the stations used as a single backside and calculate it under adjusting. The same for end station. When I hit on all available backsides, all the listed stations will be added in the calculation. Okay, the other settings are adjusting angles. You will see different options: none, equal proportions, proportional to distance. So if you set the equal proportions, the corrections will be applied equally for all traverses. But the proportional to distance means that more corrections will be applied on the longer traverses. So this time we will set as proportional to distance, and same for adjust vertical. Adjust horizontal options, there are two ways, actually three ways. First one is none, no methods for adjusting horizontal. The other one is compass bowditch and a transit one. So what are these exactly? Compass bowditch just assumes your position in angles or your directions. It's equivalent with the position in distances. But the transit rule assumes that your directions, the position of your positions in your directions is more precise than the distances, the position in the distances. So I will set compass bowditch, acting like both the precision in angles is equivalent to precision in distances. And we set the adjust manually. The status enabled means right now we are creating our first traverse. For your multiple traverses, you will be sharing some of your stations, for your future traverse creation. To use the shared stations, you need to set is enabled. If you disable it, you will use the stations this time and that won't be available. That won't be enabled to use the stations for your future traverse creation. If you click on apply, all the chains, all the computation will be applied in your project. But TBC let us to check the preview results first. So we have two panes in here. First one is settings, other one is preview results. Under preview results, you can display your traverse information, the adjustment type, the angular and vertical distributions, adjusted how many points will be adjusted in here, and your start and end point ID, your start station and station. And all the stations in right order will be listed in here. And you're gonna display the horizontal misclosure and horizontal precision, both before the adjustment and after the angular adjustment. So I can display my results in here. Horizontal precision, as well as the misclosure. You can also display the traverse length, easting, northing misclosures. All the details are just displayed in here. If you are fine with the results, with all your settings, you can hit apply and apply this and create this traverse. If you don't like, if you're unsatisfied with the results, you can go to project settings, change your project settings, change your tolerances. You can add more data and select more stations or edit your stations from the settings from this list. These are just you can do. You can also change the settings from the traverse itself in the menu. After you finish everything, you apply it and create your traverse adjustment. What we can change, I do personally like taking screenshots for my first results. Like, let me take a screenshot of it. Okay. So this is my first results. It's given in here. So I can make some chains and come back and make a comparison between each other. Since we have limited time, I would like to change a couple of things quickly. So let's start changing the adjust angles as equal proportions. Instead of proportional to distance, we will set equal proportions. So we will act like equally and just correcting my traverses. And then I will display my results. So I make the change, equal proportions. Oh, and also I would like to change the single backside and set a backside instead of adding all of them. So for my start station orientation, I set the single backside as one of those, 107, and set azimuth as default and apply it. And preview my results. Okay. So if I bring my screenshot, I hope you see the differences. So there is a certain difference on horizontal on misclosures, and after angular adjustment, you will see the horizontal misclosure and horizontal precision has changed. So on my first application, I have better misclosure and I have a higher precision on horizontal. There are different ways to make changes. So that was an example. So you can change, I don't know, settings, you can change the transit and apply it and display the results. And this is something that you need to decide at this point, because you know what errors that you are interested, what tolerances you are interested in, and you can decide your point tolerances, you can decide your manual horizontal tolerances, you can increase or decrease these values and display the chains under adjusting traverse. And there are also standard errors that we define under default standard errors. There's total station and leveling settings. These are the errors that we can set. I'm going to touch base on network adjustment. So for now, these are something that we applied on the traverse adjustment. After you finish everything and you are absolutely fine with that, you can hit on traverse adjustment report. And you can display the traverse adjustment report. And you will see your summarization of coordinate system, your project details, coordinate system, local site settings. You will see a little summarization of the process, entire process, the methods, the endpoint orientations, start station orientation. And you will also display your fixed points, reduce horizontal distances. As you see in here, our stations completely listed in here, and the forward components, and you will see the forward distances. All these values are given. And you will also display the horizontal adjustments. This is again your all stations in here. That is added your traverse adjustment, and you will see the azimuth value, adjusted azimuth value, and easting adjustment, northing adjustment. So you can print this report as PDF or Word or Excel document, or you can drag the printout from here. Trimble is quite good at reporting options, so you can access all type of reporting options over the quick access toolbar. As soon as you click on more reports, you will display different types of reports. I'm not sure which type of report you are interested in, but for your network adjustment or your traverse adjustment, you can access this type of reports. It's also possible to customize it. If you aren't satisfied with the results, you can always come back and disable this traverse and start creating a new one, or you can just clean up all the stations by clicking the first station, start station, and come back to beginning under the same traverse name and create a new one. This is how we process the traverse adjustment in TBC. Well, you will display the created traverse under Project Explorer, Traverse Networks. And if you click right and select Properties, you will display your traverse information. The status, right now it's enabled. Adjustment mode is manual adjustment. So before the adjustment, what was my misclosure and precision? And what happened after the traverse adjustment? All the stations. So I see a red under my traverse. There's a flag in here. So my traverse has failed for some reason. And the flag pane tell me that traverse failed because of the tolerance, because my horizontal precision set and it's less than the minimum horizontal precision. How I can avoid is that I can change the settings and try to catch this limit, or I can go to project settings. Under traverse, minimum horizontal precision, it was 50,000. And now it's less than this. So if I say 40,000, I said, okay, it's going to be automatically applied. And you will see that the red flag has disappeared and I am under the tolerance limits. So you can manipulate your results and get rid of those flags, changing the tolerances over the project settings. All right, so you can display your points and start, changing the tolerances and apply and come back to adjusting traverse and reapplying it. This was the first one I want to touch base. And I think we can continue with the second one. Let me check the. Yeah. So the traverse adjustment, that's the final thing I would like to say, that during your traverse adjustment, you try to eliminate some of errors in the traverse. These are centering errors. You may have errors on your height of instrument or height of your target, your prism. There might be some instrument errors such as EDM or circle errors or your level while or culmination errors. You may point somewhere different, so there might be pointing errors or there might be refraction or curvature errors. So we try to eliminate those errors by applying adjusting traverse. This is why we change all our settings in here. All right, I'm gonna continue with my second presentation, which is about network adjustment. If you don't have any question for now. All right. I decided to use separate the individual data set to perform the network and traverse adjustment, but depends on your data. You can just combine all of your data sets under one project and apply it everything, literally everything. You can get your baselines, you can process your baselines, you can get your level and total station data, you can merge your levels, adjust traverse, and then you can also bring your GPS data and apply the reference stations, and you can bring your NGS parameters over the internet download and apply all of them. Then you can apply the network adjustment. You can also perform transform survey points, merge points. It's possible to get this, apply the site calibration after we finish everything. And we can change the local site settings for scale factor change. All these processes can be applied under one project. But to be more clearer, I picked different data sets. So I'm going to use another data, which is this. All right. So the level data and the vectors is colored as purple in the TBC as default, and the total station is colored with green, and the RTK, the GPS baseline is colored with blue. And I can also display all of my data set over Project Explorer. And I can display my points, my sessions, and imported files, my static data, DAT data, orbit values, NGS orbits, level, pretty much everything is listed under import files. You can display your sessions in here, and you can display the properties of this baselines, the process baselines. And it's possible to get all the information about the baseline, how you obtain the data, how you get these, and what was your manufacture, how the method of the antenna and the height of your antenna, when and interval time, start and ending time. All these informations are given. I'm not going to apply again. And you can also access these observations over time-based view. This is absolutely as another session's topic, but you can also get some, reduce some observations and process your baselines to get better results. That will definitely affect the network adjustment. I have another presentation. I will try to talk briefly about it, but I'm not going to run all of them. So in the sessions, we will start with our agenda. We will start with how we can apply the network adjustment, how we can make the change on project settings, what kind of errors we have, and how we can eliminate them, and performing the network adjustment. There are different types of network adjustment. One of them is minimally constrained network adjustment, and another one is perform constrained network adjustment that we apply, that we include more points. We will start with minimally network adjustment, just trying to change the settings of our first point. Okay, that's better. So why we apply network adjustment? We try to eliminate some of errors that belong to our measurements, and we can categorize these errors as mistakes, blunders, that might be incorrect height of instrument, that might be incorrect ID, point ID, or that might be a wrong shot, wrong point measurement. And that might be also systematic errors, which included but not limited to temperature effects or eccentricities or the antenna phase center variations. That might be random errors, just happens, like atmospheric noise in GPS signals, or total station setup and sighting, or just small errors while you are taking the shots. This might be an observer's mistake. And we can never get rid of the random errors. They will be always there. But we can do, we can take some precautions to eliminate systematic errors or our mistakes. We are all humans, so it's quite common to make the mistakes. The network adjustment, that's actually same for traverse adjustment, but this is never ending process. So you can apply the network adjustment for hours and hours and days, constantly just changing the results step by step. That will still be some errors given in your outputs. It's just seen on the results. So this is something that you decide to stop. You will apply your first adjustment and review your results, change your settings, readjusting and review your results and decide where you're gonna stop. The first, there are some terminology, even I try to, speed up this process to finish on time. There are still some terminology we will see in the network adjustment process. That's the first one is the standard error. This is the this is actually called like it's average uncertainty of the measurements. So this is called standard deviation in mathematics. And there are some criterion that we set some limits on the standard errors. It's seen with sigma. And this is the formulation of calculating standard error. X dash is the X bars. This is the mean value. This is the average value of our observations. So N minus 1 is our degrees of freedom. And we calculate a sigma value. And we display the sigma on our histogram. The residual is the mean value minus measured value. So this is kind of an example for you. The residual is just mean distance to measured distance. So we will get all these residuals and we create kind of the histogram shows all our distance residuals. And we define the tau criteria, another criteria, and we display the sigma. Here is a sample distribution. So as you see in here, the sigma value is just, the mean value is given in here. And these are our residuals. Some of residuals just over the limits. And there is the red lines that just cause, that is just tau criterion. And what is the accuracy and precision? So we need to understand the difference between accuracy and precision. Accuracy is just nearest to truth. So this is the correct value, but we never actually know. So we will be close to accuracy, but we will never exactly point on that accuracy value. This is high accuracy, but low precision, because as you see in here, our observations are spreaded. So the precision get lows. We expect to target the center, and the most of our observations is closer to each other and on the center point. On the other hand, the precision is the measure of the consistency or degree of the refinement. So as you see in here, all our measurements, it's quite close. So this is high precision, but it's far away from the center. So low accuracy. Both of them are not good. So we need to decide how we can center the accuracy and how we can get most of our measurements. You will see the histogram differences between each other. So the sigma and the tau criterion, the limits that we set are completely different in these two histograms, two shots. These are probably more details, and I don't want to keep you till midnight. So These are the degrees of freedom, which is n-1. And redundancy. This is a little important. We will see the redundancy number. So a measure of individual observations redundancy. And we will compare the reference factor. Reference factor is the square root of the sum of the weighted squares of the residuals. And these are just different formulation that we calculate. And you will see in the network adjustment menu that the reference factor should be stated between two values. So if it's greater than 1, the errors have been underestimated. If it's less than 1, it's going to be overestimated. And Chisquare Tests that Trimble Business Center uses, and the limit is 95%. So we try to keep our observation error estimates under 95%. And you will see that if it passes the 95, it's going to be failed. Then otherwise, it's going to be pass. These are the histograms and the tau criterion. I'm going to pass this one. And for doing the network adjustment, we will change the tolerances of angles and distances. So these are the short comparison for you. So the good angle and distance is given in here. As you see, the geometrically, the circle, this is the poor distance. However, there's a good angle. The differences are quite clear in here to show the poor angle, good distance, and the poor angle and the distance. Yes, we will see on the graphic view better. And I will continue with the demonstration. I guess it's okay for now. So under Project Explorer, I'm going to display all of my points. Some of them are level points. Some of them are GPS points, GPS shots. As the mentality of TBC, we will start our process with the project settings. And we will change our settings first. So the first settings we're going to change is the network adjustment. Under network adjustment, you will see the general settings. And you will see the mean angles. Use individual observations or use mean angle results. According to the calculations over the formulation that is given, we will use the mean angle results to calculate the network adjustment. So I will change it. And perform vertical adjustment, yes. This time we have vertical data sets, so we will also perform vertical adjustment. And the second, it is computations. Under computations, second settings is mean angles. The tolerance of mean angles, we decided to perform our network adjustment using the mean angles. And now we decide to tolerance for that. The horizontal set as 5 seconds. I'm going to change it as 7. This is again a sample. You can play with it. I generally don't make any change on slop distance. Other one is default standard errors. Under default standard errors, TBC give you 2 options. So you can use your source file as your important files. If you get your data using a field software like Trimble Access or Survey Pro, you will set some settings for your total station, the collection of your total station shots, or your level points, or your GNSS points. So in this menu, you decide which kind of settings you will get. If you select imported files, all the settings from the raw data will be applied into the project. So we need to decide source for standard errors or source for centering errors. I will change source for centering errors as project settings because we have sub settings in here that we can change it. Under leveling, this is source for standard errors. I will also change my standard errors source for project settings and reference my own settings. Second one is the total station. So under total station, you will see the horizontal, first the default standard errors and centering errors. We all know that there is no way to center our instrument with 100% perfectly. There always be centering errors for your instrument, same for backside centering errors. This will always be. So I will set as 2, like 2 millimeter for now. And same for standard errors, horizontal and vertical. 1 second is too tight for displaying the differences. I will change it as 5 seconds. I'm not going to change the slot distance. And the default height errors, error in height of instrument. So this is something, you know, you have a tape, you try to measure your the instruments or measure your prism, your pole. There's always some possibilities to get some errors on that side. So I will keep saying as 2 millimeter. And the second, you can also make some changes on the additional error types. So angle offsets, distance offsets, according to your interest, your raw data, you can make the changes. Under leveling, since we brought into the project, we brought the level data too, I can also make those level data as my network adjustment. I add them and I can set the errors. Default standard error on 1 kilometer of double leveling. This kind of settings generally given by the manufacturer, by vendors. This project, the DINI level, Trimble brand DINI level has been used. So I'm gonna set the default standard error as 0. And default standard error for each station setup is 3 millimeter. This is something that's a kind of standard error that we set. And the last part is the standard errors for our GNSS shots, GPS points. So I see the error on horizontal and vertical. There's also instrument centering error. You know, our pole can be moved a little bit, or there might be some errors on the height of the antenna. Depends on, you know, some of receivers has the antenna internal. Some of them we just use out of the pole. So it's quite normal to have some errors on that side too. What I can do at this point, I'm gonna keep these errors horizontal and vertical as same, but centering errors never be the 0. I mean, under atmospheric conditions, it's a little difficult to get perfect result on that side. So I'm gonna set is 5 millimeter, and 2 millimeters. After I made all my settings, like I finished network adjustment settings, default standard errors, I decide all my errors, my tolerances, I decide my mean angles, and also apply the mean angle settings. After I finish everything, I said OK. And the data will be recomputed according to the change I made. It's going to automatically be applied as soon as you click on OK. So you don't have to compute again. And we will continue with Survey tab, Adjust Network. You will see two panels, two menus. The first one is Constraints. The other one is Weighting. After you apply the adjustment, you will see the results. For this data, it's really important to know your data sets and what you have in here. So right now we have 13 points. 10 of them are level points and 3 of them are GPS points. As an example, I'm going to start with changing the settings for 2D and height. So sigma set as 0. I will hit adjust. There are still 8 unresolved project computation errors. You can say OK and just skip the errors for this time. OK. So I will see the reference factor as 1.35, which is not good. And my Chi-square test has failed. So as you see, it's quite poor at this point. And degrees of freedom is 268. So what am I going to do with it? I see some points, some flags in here, 2 points. Probably these are computational. These are horizontal point tolerance exits. Okay. So what I can do is, after seeing the results, I can go to Network Adjustment Report. It's in HTML format. And you will see the left panel that you can switch to sections in your network report. You will first see the project file data and coordinate system briefly. And for all the adjusted observations, like your GNSS observations, total station observations, leveling observations, all the adjusted points will be in here. So we can click on Adjusted GNSS Observations and display why my Chi test failed. And I see that I have 2 observations in here that doesn't satisfy the tau criterion. So I can come back in my menu. If I hit on TMGO, this observations, I will see under Adjust Network menu, I will display it. So delta height is 0.042. How that affects the failing? I guess the best way to display it, just check the histogram of standardized residuals. So that's my histogram. And I see the tau criterion, tau value. So this exceeds the tau criterion. It's somewhere out of it. And we don't like it. So what we can do is we eliminate these observations. Since we have enough degrees of freedom and we are not bad on the reference factor, we can eliminate this observation. That's the same for the other one, the filter. So as you see in here, delta height is 0.021. So it's over 20 centimeter. So what I can do is just go to my Project Explorer. I know that my first point is TMGO. Go there and let me. As soon as I select the TMGO, I will display just color with yellow. This is my observation. There are two ways to disable this observation. First one is click right and hit on disable vectors. Another one is go to properties, display my observation settings. And under that, under status, I will say disable. Since we already adjusted our network, so it's asking me if I want to keep the adjustment or clear the adjustment. I can't keep the adjustment while I'm eliminating one of the vectors because this is also including calculations of the reference factor and the chi-square test. So what I can do, I can clear the adjustment. It's gone. So if I come back my report, I know that another point, filter to 5. This observation is also exceeds. I can go to filter to 5, and I say disable. I have already cleared my adjustment. You can also clear from your bar under the adjust network menu. So you can clear your results and then readjust. There are still 8 unresolved project computation errors. These are more likely the flags, describing the flags, and this is because of my exist of my tolerances. So I can say continue on the adjusting network. Okay, so I see that my chi-square test has failed again. The degrees of freedom just decreased because of I just disabled some of my vectors. The reference factor is decreased too. I can check the weighting. So as you see in here, we have reference factor, scalar, and redundancy. To have a better redundancy, we need to something on the reference factor. So in here, you will see the vertical angles. The reference factors of vertical angles is little high. And our goal is setting the reference factor between 0.95 to 1.05. Right now, my post-process vectors is 1.04, which is fine. So just removing some of, disabling some of my vectors doesn't help me at this point. I should weight my vertical angles. Then I'm gonna apply a scalar. By clicking this star, I just equal my reference factor to scalar. If I adjust again, still asking me that there are unresolved project computation errors, say go process, and my vertical angles is just leaning on 1.22. What about my results? I passed. So chi-square test passed this time, and I have a reference factor 0.99. My goal was keeping my reference factors between 0.95 to 1.05. So I passed, I'm fine. Has it over? Are we done? No. We can continue, keep going our enhancing, developing our results. How I can do this? So I can say I'm gonna click on leveling and weight and just weight my leveling, my reference factor with scalar and adjusting. And I'm gonna display. I don't see anything. Or let's continue with the horizontal angles. You will display the post-process vectors, reference factors. The scalar and redundancy will be changed whenever you just wait your results. So the settings change over project settings, the settings on your default standard errors, or your, your mean angles or individual observations, your computation settings, your mean angle settings, horizontal angles and vertical angles. These are quite important for having the results on the reference factor. So whenever you change, you will see some change on your reference factor directly. You can decide which observation you will include on your network adjustment. You can always display your network report and check your histogram. How is your sigma? How is your tau criterion? Is there any fail? You can also check your adjusted genesis observations. Since we are standing on the results, we only have one observation just failed on the tau criterion. So you can disable this vector, or maybe you can come back to your project explorer, disable and recompute, or you can just leave it like that. At this point, you are the one decide where you want to stop it, because it's keep going. When you disable this one and readjust, maybe you have different observation just phase on the tau criterion. Maybe not. All these informations, all your results, your errors, your geodetic coordinates, your adjusted grid coordinates are given for each point ID. All the information and statistics are given under the network adjustment report. You can also print out this type of report from more reports or network adjustment report. Yeah, I'm not sure that if you can get in PDF format or other, but of course you can save using Control P in the print. If you don't like all the results, you don't have to just close up or delete the project. Just go the adjust network menu bar, clear adjustment results. They're gonna wipe out all the chains that you made for the adjustment. You can also direct access from project settings. It's gonna bring you the default standard errors. And there are different report options for ALTA and SPS, relative tolerance reports. Since we haven't applied any, RTX solutions or processing services, or we didn't bring any solutions over the internet download, so I'm not going to touch base that site. I guess, let me check if I have anything else. So I believe this is briefly how we perform the traverse adjustment and network adjustment. Well, yes. So if you say OK, you can close up. You will display the name adjusting the network, your project file. Everything will be standing in here. Yeah. Well, this is how briefly we handle processing, adjusting traverse and network adjustment in TBC. If you have any question, I would love to answer. If I can't, I can investigate it and come back to you if you give me your contact details. I hope it's not very confused for you. I try to eliminate some of information because it deeps, and it's in one point it relates with the some algebraic formulations and mathematics. So I just try to make it some simple and clear and try to fit in an hour, 1.5 hours. But we generally perform each traverse adjustment and network adjustment as separately. Each one of them has like 2-hour sessions, maybe 3-hour sessions, because we still keep going on doing these things. And there are different parameters that we need to handle. Yeah.
That was awesome. Thank you. Anybody got questions? No, it's pretty deep. It's pretty deep stuff to go through on the software side. So
I guess we have a question.
let's see.
Okay. I guess it is under
Chat. Could you explain how to explain show slide on standardized residuals? You skipped over that.
Yeah, I just a little worried about finishing a little bit late. Okay. All right. So standardized residuals. We need to define two parameters before doing this, actually. Let me. Okay, so we have priori errors and posteriori errors. Priori errors, the errors basically before the adjustment. And the posteriori errors is a special estimates referencing the priori errors. And that is calculated after you applied, after this is the post-adjustment error estimates. Posterior reference the prior errors, but this is made after you finish the adjustment. After that, okay, you will see the standardized residuals, standard errors. So this is the observation residual divided by a posterior standard error of that residual. So we make all residuals in one system and we compare those residuals. This is why we applied the histogram. So we get all the mean and we get all the calculations like mean angles and our observed angles. We just use these calculations and get the residuals between each other, like mean angle, mean values minus your observed values. So we get all these residuals by calculating this part, and then we get kind of pool for getting all the standardized residuals and display in a graphic. And you will see the standardized residual, some of them is just passing the graph. So the graph is standard residual, and this is less than tau criteria. So under the graph, you see that all these values, these are less than tau, and these are our residuals. But the standardized, the mean value is just centering on my residual, but it's on top. This is how we just explain this part. So if it's just passing the critical value, it's failing on the standardized residuals. Means that this side, our standardized residuals is falling and it's failing. It's outliers. What I can say is this allows us the residues for different measurement types be combined during the analysis, and like applying these residuals, like letting the entire network and compare on a specific field. It's important to how many how many numbers of points have the similar residuals, and this is lean on in a graph, and we display it. So imagine that you have 5 to 10 observations have the similar standard residuals, and it's between to our sigma value to 1, 2, 3, and it's spread like this. And it's distributed in the histogram. I personally recommend you a surveying book I reference, because some of information, some of terminologies are also not familiar for me since I'm not a surveyor. So I use Gilani's elementary surveying book. It helped me a lot. It's very common in the universities. Maybe that's somewhere that you can reference and find more information, because I know that there is a chapter, adjustment traverse, in that book. It just helps you exactly calculate all the residuals and standardized residuals and mean that. Yes, your question, Sean. Is there an option during traverse adjustment to use a least squares method? Yes. Let me remember. I should figure out where I put it. Where is it? Let's say, okay. So I just traverse. Okay. I guess I need to check it. Let me take this my note. I know that there is an option. Oh no. Let me check this one. TBC, the Trimble team, sometimes sets some of options as default, leave like that, since the risk of mixing everything. So I try to figure out, is there a way to switch this? Okay, I'm gonna double check this with Trimble and get back to you on that side.
Hey, Sean, we're going to do some stuff next week with StarNet as well, which will be the more of the least square side. So, but we can always follow up with some of the additional stuff and throw it in the Dropbox. Gizem.
Yeah, I will be sharing the presentations. I want to add some of details. Maybe I can also add some technical info about standardized residuals. And maybe I can get some screenshots from the menu. So that might be refreshing for you for feature.
Okay, cool.
I will share those presentations in there, and I want to share the instructions, the tutorials. It was like 25, 50 pages per each. So they also have sample data set, which these ones. So you can basically open the TBC and perform all of these over the instruction. It gives you step by step, and it has screenshots over the menu. So no worries about that. Today, when I talk, I especially pick the tutorials. I know that some of attendees are just beginners, so they will be more comfortable if they see kind of instruction guide and shows like step one by one. And if you need any TBC temporary license, like monthly license, I can provide you, so you don't have to worry about that. And as soon as you get your temporary license, you can download the software from Trimble's website, and you get the codes, apply it, and you can open your sample data in here and play with it.
Oh, that'd be awesome. Thank you.
Right.
Anybody else got any more questions? Awful quiet. I'm sure a few people have some headaches.
I am so sorry for that. I just,
It's all right. It's not an easy topic.
Oh, this is awesome. It was a really great presentation.
Yeah.
You know, it's kind of a high speed thing to be going through, and
Exactly.
you know, if everybody already had TBC and the data set, they could be working along with you on it. But you know, at least seeing how these all fit together and the processes, you work through the processes, and this ties back down to the statistics talks I gave a couple of weeks ago, and it'll tie into start it next week and kind of build on these things.
Exactly.
for me, it is like, I know that there are many settings, so it's quite easy to forget, to miss, especially for future next couple of weeks. You will start not remembering some part of it. So I first thought about sharing all this information on Dropbox before the session, but I decided to perform exactly this way today. So I thought that maybe directly showing the demonstration instead of drowning you slides and slides, probably better to remember. So all this information will be in the slides anyway. You can always come back. I don't know. There are different power hours. Trimble has great resources, and they try to develop online trainings after the COVID outbreak. So under the support tab, you will see all the resources they have. I references the tutorials from their website. So this is exactly downloaded from there. If you have any type of question for this week or next week, you can come here and downloading the adjusting network, downloading the adjusting traverses. So you will get a zip package, includes both the instruction in PDF format as well as the sample data. And same for power hours. This is, we always advise our customers to access the power hours because you will see lots of video, lots of online webinars about your applications. I know that you are interested in different things like land surveying, and there's also a special section for Trimble Business Center. So if you click on there, you will get all the lists. And even the last week, they performed network adjustment. It was just last week, and 1.5 hour sessions. It was a recap, network adjustment, and you will see the utilizing level editor. If you say Control F, you can just type network and get all the power hours. This is just something like this today, something similar video that we performed today. But the topics are different. So you can also refresh your minds from there. There is a community I like following up the community. You can ask any type of question from there. So you can enroll this community to ask your questions, and everybody all around the world in here is for you. So customers, students, users, professors, Trimble team, all the dealers, we try to reply all of our customers' question or make some comments. If you have any problem about understanding the errors or any settings in the network adjustment, you can also reference this part. So everything is in here just for you. You can just click on it and being, reference being forwarded to related website and get all the information. Of course, I will be in here. I forgot to add my contact details somewhere. Again, that's kind of my habit. I always forget my contact details adding the presentations. I'm sorry, but you can find my emails probably.
Yeah, I'll put it out to everybody tonight as well when we.
Thank you.
When we
I'm sorry.
Oh, you're fine. Exactly. No worries.
Yeah.
Super helpful with the tutorials and all that kind of stuff. So I'll try to grab all those links as well.
Okay. Perfect. Just let me know if you need the demo licenses, and we can provide it to you.
Got it. Thank you very much.
Yeah.
Anybody else got anything?
Thank you.
I think we're good. That was awesome. Thank you.
Thank you so much, Gizem.
Thank you so much. Have a great evening. Have a great night for all of you.
See ya.
Okay, we'll see you next week.
Got it. Bye, guys.
Okay, thank you.
Thanks.
Thank you.